Welcome to video lecture on ceramics, clay products and refractories. Ceramics. The term ceramics is used to indicate the potter's art or articles made by the potter. It is derived from the Greek word keramis, meaning potter's head. The ceramic products are broadly divided into the following three categories: clay product, refractories and glass. Clay products. Clay occurs plenty in nature. Clay is a distinct product of chemical weathering of igneous rocks. Feldspar is predominant in igneous rocks. One of the variety of feldspar is orthoclase feldspar. It is white, grey or pinkish in color. Rock disintegrate easily if orthoclase feldspar is in abundance. Thus, orthoclase feldspar is mainly responsible for the production of clays in nature. This mineral on decomposition gives kaolinite, which is free from iron oxide and alkalis. The term kaolinite is used to indicate the product having composition of pure kaolinite. In kaolin, alumina and silica are compounds held in colloidal state, and these compounds form the basic constant of all clays. In addition to these compounds, various other materials such as silicates of calcium and magnesium, iron oxide, free sand, sodium, magnesium, chromium, etc. also occur in clays in small proportions. Clay, when made wet with water, possesses high degree of tenacity and plasticity. Such plastic clay can be molded in desired shapes. It is then dried and burnt. Clay contains water in two forms, namely free water and combined water. Free water is removed during drying. The chemically combined water will be removed when the clay is heated to a high temperature. At this stage, chemical changes occur among the constituents of clay and new products are formed which are hard and compact. Beyond a certain limit of temperature, the clay becomes soft products and the products lose their shapes. This limit of temperature will depend on quality of clay. The clay products which are employed in building industries are tile, terracotta, earthenwares, stonewares, porcelain and bricks. Tiles. Tiles are used for variety of purposes in building industry. They are thinner than bricks and hence should be carefully handled to avoid any damage to them. Manufacture of tiles. Following the four distinct operations involved in the general manufacturing of tiles: preparation of clay, molding, drying and burning. Characteristics of good tile. It should be free from any cracks, flaws or bends. It should be regular in shape and size. It should be sound, hard and durable. It should be well burnt. It should give a clear ringing sound when struck with hand or with one another or with light hammer. You should fit in properly when placed in position. You should give an even and compact structure when seen on its broken surface. You should possess uniform color. Types of tiles. Depending on the use to which the tiles are put, the following are different types: drain tiles, floor tiles and roof tiles. Drain tiles. These tiles are prepared in such a way that they retain porous texture after burning. Hence, when such tiles are laid in waterlogged areas, they allow subsoil water to pass through the skeleton. These drains may be circular, semicircular or segmental. They are also used to convey irrigation water. Such drain tiles are rarely adopted in modern times. So the image shows the one of the types of drain tiles. Floor tiles. Floor tiles may be square or hexagonal in shape. These are flat tiles and their thickness varies from 12 to 50 mm. Size of square tiles varies from 150 to 300 mm. Floor tiles should be hard and compact so that they can resist wear and tear in a better way. Floor tiles with thin section can be adopted for ceiling also. To prepare colored tiles, coloring substance is added in the clay at the time of its preparation. Floor tiles of comparatively less strength can be adopted for fixing on walls. Roof tiles. These are used to serve as covering for pitched roof. Various types of roof tiles are available in the market. Their important variety are as follows: Allahabad tiles. All these tiles are made up from selected clay. Molding of clay is done under pressure in machines. Burning of this tile is done in such a way that they attain more strength. These tiles are provided with projection so that they interlock with each other when placed in position. Tiles of special shapes are made for hip, ridge and valley portions of the roof. The image shows the Allahabad tile. Corrugated tiles. These tiles have corrugations and when they are placed in position, A side lap of one or two corrugations is formed. Placing of such tiles on roof gives an appearance of corrugated galvanized iron sheets. Flat tiles. These are ordinary floor tiles. To fix them on battens, two or more holes are provided on the surface. Suitable laps are provided at sides and edges. Mangled tiles. These tiles are flat pattern and they are provided with suitable projections so that they interlock with each other when placed in position. These tiles are red in color and made of double channeled basal mission mangled pattern. Special mangrove tiles are available for hip, ridge and valley portions of the roof. It is found that about 15 mangrove tiles are required for covering 1 square meter of roof area. The image shows the mangrove tiles and the flat tiles. Pan tiles. These tiles are short and heavy. They are less curved than pot tiles. Such tiles are molded flat first and then they are given a required curvature by molding in suitable forms. Drying and burning of tiles are done carefully to get better quality of tiles. Pot tiles. These are ordinary off-round country tiles. They are prepared on potter's wheel and shape is given to such tiles by a potter with his wet hands. Polishing of inner and outer surface is done either with a wet cloth or a wetted strip of leather. These tiles are semicircular in section and their length is about 20 cm. They are placed on the roof with their concave and convex sides uppermost alternatively. An overlap of at least 80 mm is provided at edges. When these tiles are used, these tiles are liable to break easily and hence they require frequent replacement. The image shows the pot tiles. Terracotta. Terra means earth and cotta means baked, hence terracotta means baked earth. It is a type of earthenware. Varieties of terracotta. Terracotta articles are of following two types, porous and polished. Porous terracotta. To prepare porous terracotta, sawdust or ground cork is added in clay before the stage of molding. When articles of such clay are burnt in kiln, organic particles are burnt and they leave pores in the articles. Porous terracotta is a fireproof and soundproof material. It can be sawn and nailed easily with nails, screws, etc. It is light in weight but is structurally weak. Polished terracotta. This is also known as fine terracotta or faience. To obtain this variety of terracotta, articles are burned at low temperature of about 650 degrees centigrade. First burning is known as biscuiting. Articles brought to biscuit stage are removed from kiln and are allowed to cool down. Then they are coated with glazing compound and burnt again in the kiln at a temperature of about 1200 degrees centigrade. Faience is available in variety of colors and it indicates superior quality of terracotta. So the image shows the porous and the polished terracotta. Uses of terracotta. Hollow terracotta blocks are used for various ornamental purposes such as facing works, arches, cornices, casing for columns, etc. It is adapted for ornamental work. It is used as a decorative material in the place of stones. Refractories. The term refractories is used to indicate substances that are able to resist high temperature. The desired property of refractories are as follows. It must possess excellent resistance to rapid changes in temperature. Its dimensional stability, that is resistance to change in volume at high temperature, should be excellent. It should be strong. It should have a high compressive tensile in hot and cold condition. It should not fall into pieces at high temperatures. Its melting point should be high. Its thermal conductivity should be suitable for the purpose for which it is to be used. Classification of refractory materials. The refractory materials are classified in the following two ways, according to chemical properties and according to resistance to temperature. According to chemical properties, the refractory materials are divided into following three categories: acid, basic, and neutral. According to their capacity to resist temperature, low quality and high quality. Acid refractory materials. So the name of the acid refractory materials are fire clay, quartzite, silica. The fire clay, its important constituents are alumina and silica. It is used for the manufacture of fire bricks, crucibles, lining materials for furnaces, hollow tiles, etc. Quartzite, it is a metamorphic stone. It is hard, brittle, crystalline, and compact. It is used for making silica bricks. Silica, it is available in the form of sand with some impurities from the bed. It is used for preparing silica bricks, coke oven, and lining for glass furnace. Basic refractory materials. Dolomite, it is carbonate of lime and magnesium. It is used for making refractory bricks. Magnesia, it is available in crystalline form. It melts at 2800 degrees centigrade. It is used for preparing magnesia bricks. Neutral bricks. Bauxite. It is mixed with clay and finely ground. Its melting point is 1200 degrees centigrade. It is an amorphous substance with dirty white, brown, red or dish brown color. It is used for preparing fire clay bricks containing more percentage of silica. Carbon. It is available in three forms: amorphous, graphite and diamond. Its melting point is 3500 degrees centigrade. It is used as activated carbon, absorbent, catalyst, etc. It is used as lining material for furnaces. Chromite. It is the oxide of iron and chromium. It is the most powerful neutral refractory material. Forsterite. It does on fall especially, and it maintains well its volume at high temperature. It is widely used in furnace for melting copper. Low quality refractory materials are used in manufacture of fire bricks as lining material for furnaces, etc. The melting point for such material is more than 1580 degrees centigrade. High quality refractory materials are stable even at high temperature, and they are used in the construction of modern aeroplanes such as rocket jets, etc. These materials are composed of either pure clay or metals or combination of clay and metals. High quality refractory materials containing pure clay or pure oxides of alumina, magnesia, etc. or nitrides of carbides. Those metals which melt at high temperature of about 1600 degrees centigrade can be used as metal refractories. So thanks for watching.